Good afternoon. So we are moving on through topic 12 to the idea of proportionality. And we talked about proportionality briefly in lesson 12-1, and we're really going to focus on it today. So we want to be able to show that two or more sets of numbers have a proportional relationship. Okay. Proportionate relationships can be represented by equivalent ratios. Now, you've been studying equivalent ratios for a while now. Okay. If you have a series of equivalent ratios, they all simplify to the same ratio, then you have a proportional relationship. To find out if ratios are proportionate, you want to simplify all the ratios or increase them to a common denominator. Okay. If they match, they are proportionate. Okay. We want the same, and I'll write it in all caps, basic ratio. If it's in a graph, the line must be straight with all points included. You can't just, skip that one that didn't match. And the line must pass through the origin. Okay? If that happens, if you graph a series of values and the line is straight and it passes through the origin, that x, 0, 0 on a coordinate plane, then you know you have a proportionate relationship. In an equation, this right here is your formula for a proportionate relationship. M represents the basic ratio and the slope of the line. It can be called constant of proportionality. It can be called slope. As you move farther through graphing, it'll get more names. Okay, so here are a couple examples. Now, one is in a table and the other is in a graph. Now, remember when we talked about these, okay, we said that when we write a ratio from coordinate pairs, okay, you're going to write your ratio as y over x. Now, the coordinate pair here would be 2, 1. That's its location on the graph. That's its address. Remember from lesson 12-1. But the proportion is y over x. So 1 to 2. Well, this proportion is 2 to 4. But if we simplify that, isn't that 1 to 2? This one, y over x, would be 3 to 6. Again, if we simplify that, 1 to 2, this one would be 4 to 8. Simplifying. Okay. And notice, remember I said that this spot right here, M, is the basic ratio or the point of the line? Or the slope of the line? Look at that. It matches the equation. So now let's take a look at the graph. Again, we have this spot right here. 2, 1. That's this first dot right here. It shows a proportional relationship of moving up 1 on the y-axis and moving over 2 on the x-axis. So that's its proportion. This one moved up 2 and over 4, which is equal to 1/2. And we could keep going. So this is how the table, the coordinate pairs, the graph, and the equation all work together as different displays of the same information. They're useful for different things. And as you go through further studies, 7th grade, 8th grade, definitely into high school, you are going to continue to use these tools of table, graph, and equation to show relationships. Now, notice in a proportional relationship, it has to go through the origin. If it doesn't touch the origin, okay, then it is not proportional. And we will attack that at a later future study, okay? For now, we're only focusing on proportional ones. Now, what if you're just given 2 ratios and asked if they're proportionate? Well, let's look. Are these 2 proportionate? How do we know? Are these 2 proportionate? How do we know? Let's take a look. Okay. Proportionate relationships can be represented by equivalent ratios. To find if they're proportional, simplify to the same basic ratio. Now, if it's easier to make a common denominator, do that, but we already did that with equivalent ratios. You guys know that just simplifying is so much easier. So in this one, 2/8 simplifies to 1/4. 3/12, if I divide both the numerator and the denominator by 3, simplifies to 1/4. So this is a yes, they're proportional. Okay, what about this one? 6/15. Well, they have a 3 in common. So 6 divided by 3 is 2. 15 divided by 3 is 5. Okay. These have a 3 in common as well. 9 divided by 3 is 3. 18 divided by 3 is 6. Oh, I can go even further. 2/5 versus 1/2. No. They're close. Okay, but 2/5 is not the same as 1/2. They are not proportional. So I want you to do your try problems, apply what you've seen here, and I will see you in class.